Hello and good evening. CSI 158, Section 841 and 847 students for the Spring 2014 semester at Anne Arundel Community College. Tonight's PacketTracer tutorial is going to be the Skills Integration Challenge, and it's PacketTracer 3.4.1.2. And these are some of the most enjoyable exercises because it really takes all of the things that you've been working on and pulls them together into one PacketTracer activity that you need to knock out. And interestingly enough, this PacketTracer has a couple of what appear to be mistakes, and so we'll talk about those two mistakes. Specifically, it looks like it asks you to do some stuff when you go to check your results. However, it does not ask you to do those things here in the requirements section. At least I did not see them. So okay, let's jump in and let's see what happens. So switch 1 and 2 are fully configured, so everything we do is going to take place on switch 3. And let me remember to do this. Seems like I always forget. Okay. So all of our work in this PacketTracer will be on switch 3. Whoops. It's going to be on switch 3. So let's pull the command line interface up for the Cisco iOS here. So IP addressing and default gateway configuration need to be configured according to the addressing table. So let's jump in from user exec to privilege exec into global config. And so create, name, and assign VLANs according to the VLANs and port assignment table. So let's go ahead and knock the VLANs out first. So we'll do VLAN 10, and the name of that VLAN is sales. Then we'll do VLAN 20, and the name is production. And then we'll do VLAN 30, and the name is marketing. And then we're going to do VLAN 88, and the name is, oops, whoops, left the name off. Name is management. And finally VLAN 99, and the name is native. All right, so there's the creation of all of our VLANs. You can see here our score has jumped up. We're now 30 out of 100. And so we'll continue on here. So it says create, name, and assign the VLANs. And so here's where we're going to go ahead and assign those VLANs that we just created to the ports that are listed next to those VLANs. So I'm going to do interface range FA0/1 to FA0/6. And we're going to go ahead and say switch port mode access and switch port access VLAN 30. And then we're going to do int range FA0/13 to 20. And those are going to be switch port mode access and switch port access VLAN 20. And then finally, int range FA0/7 to 12. And switch port mode access, and then switch port access VLAN 10. All right, so we've assigned all of the interfaces to the respective VLANs. Now you'll notice that there's a VLAN 88, and so we're going to get to that in a second here. So let's make sure that we do the management VLAN, and that is that VLAN 88, and that'll be done. Let me check. I don't see it below, so we'll go ahead and do that now. So interface VLAN 88, and the state is changed to up. I always do no shut, even though you don't have to. I always do that out of habit. And left the other ports shut down, and we'll get to that in a second because it's going to ask us to keep a lot of those ports shut down, so we're only going to activate certain ports. So interface VLAN 88, and so the IP address on switch 3 is going to be 172.31.88.4. Oh, whoops. And we're going to put our subnet mask in there. Right, and so this, again, this is for management traffic, right? This is our management VLAN. So we've got that added in here, and it says the default gateway needs to be configured as well, so we'll oops, we'll exit out here. We'll do IP default gateway, which is going to be 172.31.88.1. And what's important about this command here is, again, this is the default gateway for our control plane traffic, right? Traffic generated by the switch, by switch 3. So that is not the default gateway. This statement right here is not the default gateway for PC4 and PC5 and PC6, right? Or it's not this statement, I should say. The better way to put it is, it's not this configuration statement here that creates a default gateway on switch 3 that somehow routes the traffic. So this statement is only for switch 3's control plane traffic, right? So if I ping, if I trace route, that's my default gateway. Okay, so we've got that taken care of. So we're 50 out of 100 right now. We still have a number of tasks to go. So assign the native VLAN 99 to the trunk port and disable dynamic trunking protocol. And so I actually had one of my subscribers contact me asking for some clarification as to how do you know that that is a trunk port, right? And so actually let me start desk scribble. Yeah, we'll be good there. And we'll do Control N to clear the screen. So the question from my subscriber was, how do I know which port is supposed to be the trunk port, right? And they had said that they assumed it would be this port here, and holy Toledo. Let me drop the size of the line down there. Said that that was going to be the trunk port, right? And remember, a trunk port typically, right, not always, especially not today. So if this was a hypervisor, right, like let's say this was a VMware hypervisor of some kind, then this could be a trunk port, right? So it's an access port here, okay, because it's just a single PC. But if this were a hypervisor, like a VMware or Hyper-V, that could be a trunk port. So, but for the CCNA purpose, we know that between two switches is typically where that trunk port is going to be, right? And so it's going to be gig 02, and it's on gig 02 that we're going to go ahead and configure that trunk port. And so if I pull switch 3 back up, let me get rid of that first, and let's get switch 3 back up here. All right. So if I do a do show interface trunk, there are no trunk interfaces right now, but we know that we've got multiple VLANs on switch 3, right? So we've already seen where we have a VLAN 10, a VLAN 20, and a VLAN 30. And so that's how we know that we're going to have to do a trunk port here if we want to allow these PCs on this side to talk to the PCs over on that side. This would have to be a trunk port to allow those VLANs, to allow the multiple VLANs to transit this trunk port to make it down this path. So that's why we know that that's going to be the trunk port, right? And hopefully that makes sense. Okay, so let's go back here to the cursor. Okay, so we're going to go into interface gig 02, and we're going to say switch port mode trunk, and we're going to say no shut, make sure there, and then switch port trunk VLAN, or allowed VLANs, or actually not the allowed, the native. So let's do the native VLAN first. Native VLAN 99, and so that'll be the native VLAN for that trunk port. And then it says right here, disable DTP. And so I've actually pulled up a PDF from the Cisco Learning Network site that talks, does a great job right here in Figure 2, and talks about the different dynamic trunking protocol modes, right? So by default on switches, all switch ports are really trunk ports underneath, right? If you do switch port mode access, you actually have to run the command to change the port from a trunk port to an access mode port, and that's why we run that command, switch port mode access. So then there are some dynamic trunking protocol modes where you can set the modes, or they're set by default, so that the trunk can establish itself or not establish itself. And so here are the modes here. So switch port mode, dynamic desirable, dynamic auto, switch port mode trunk, and this hard codes the state of, I should say, the state of the trunk port, right, to on. And then switch port no negotiate. And switch port no negotiate prevents the interface from generating dynamic trunking protocol frames. So when I set the switch port to no negotiate, what I'm saying is the port very well may be a trunk port. I may have switch port mode trunk turned on, hard-coded on the port, but I do not want it to generate dynamic trunking protocol frames. And so this is the command here that will be used to turn off DTP. So I would type in here switch port no negotiate, and that is going to deter, or it's actually going to suppress, the dynamic trunking protocol frames from being sent out on that port. All right, so then restrict the trunk to only allow VLANs 10, 20, 30, 88, and 99. So switch port trunk allowed, VLANs, and so we're going to say 10, 20, 30, 88, and 99. All right, and as you can see, the unblock consistency is over with, and the port consistency has been restored. And we should see this port go green here shortly. And so, and there it goes. All right, so we're looking good there. So now if I do a do show int trunk, you can see that the mode is on because we did the switch port mode trunk. The encapsulation is .1Q. Now we didn't set that, but it's set for us by PacketTracer. Status is trunking, and the native VLAN is 99. And here are a list of the VLANs allowed to transit that trunk. And so now that's been fully configured. And so to pull back the conversation here to the actual Cisco switch to talk about the modes that you see. So this is a 3550. So if I do a do show int trunk, right, you can see that the mode is desirable. Okay, and so back over here, dynamic desirable. So on the 3550, that's the mode that these interfaces were in by default, right? And so that's one of the modes. And so on the 3550, you may see dynamic desirable. Let's see on a 3750. Let's take a look and do a show int trunk, right? And then these are dynamic auto. Okay, and you can see some of them are negotiating 802.1Q, some are negotiating ISL. Okay, and so that's where you would see the mode of the trunk. You know, is it dynamic desirable? Is it dynamic auto? Or is it switch port mode trunk or switch port no negotiate? Have those been set? Or is it an access port? And again, remember that we said that by default, the interfaces on a switch, by default, they're all trunk ports natively. And like I said, you've got to run that switch port mode access command like we've been doing in order to force it to be an access port. Okay, so hopefully that makes some sense there. So the native VLAN is set. So configure basic security. So we need an encrypted secret password. So we're going to go enable secret, and I think we're going to do unencrypted for what we're typing in here, and it's going to be it's a secret, right? And so that's how you would enable that and type that in. The console password of let me in, so line con 0 password let me in. And then line VTY, the VTY line 0 through 15, the password for those is going to be C1 $, lowercase c 0. So a very tricky way to spell Cisco. So that's been set. And now encrypt plain text passwords, and so that is the service password encryption that encrypts those plain text passwords. So before I run that command, let's take a look at a do show run. Right, you can see the enable secret is already encrypted. If I come down to the console lines, you can see that it's not, right? So that was the plain text we entered in for Cisco, and there's let me in. So you don't want that. So we want to do service password encryption, and then if I do a do show run, now we've got the passwords entered down here, although this is a very weak encryption, right? It's I'm drawing a blank here. It's basically the version 7 of the encrypted password. There's different types of encryption that are used, and so this is not MD5. This is a very weak encryption here, and in fact, you can actually take this, and in fact, let's do that. If I copy this password here from the service password encryption command, is what it's done, and do crack Cisco type 7, thank you. So type 7 passwords. So decrypt type 7 passwords. So let's paste in what we had there. So there it is, and I'll type submit, and your password is let me in. So if you use a type 7 password, it is extremely easy to crack that password. And so let's grab this one and see if it holds true here. So let's copy, come up here and decrypt another password. So we'll type it in, and there it is. So this is just simply to make it so that the password isn't there in plain text. But as you can see, it took us all of about 5 seconds to Google decrypt Cisco type 7 passwords and to decrypt both of those passwords. All right, so type 7 is very weak. There are some other types. There's type 4, type 5. Type 4 has had some issues. But again, Cisco has openly said that their encryption methods, right, for the passwords are not meant to be uncrackable. They're simply meant to provide minimal security so that someone looking over your shoulder doesn't see the password. All right, so enough on the passwords. Okay, so encrypted plain text password. So MOTD banner. So we're going to say banner MOTD, and I'll use the $ for the end of line character, the end of the command character, and so it's authorized access only, bang bang, and then the $. So that's done. So now it says disable unused ports, and so we can see we're using 11, 18, and 6. So we're going to go ahead and do show run. Let me see what we've got here. So I'm going to go ahead and say int range, or actually let me do show interface brief. Oh, it doesn't, or sorry, do show IP int brief. All right, so as you can see, down, down, down. So 6 is up, 18 is up. Was 11 up? And 11 is up. The rest are shut down. VLAN 1 is administratively down, but gig 02, so good. So it looks like those guys are in fact actually already shut down. All right, so now let's do a little port security. So it says configure port security on FA0/6. So if I do an int FA0/6, remember I need to start out with the switch port security command by itself, right? You can see here where it says, hey, you can just type this in, and at this point we can do a carriage return, and we need to do that to enable the security. So it says only 2 unique devices are allowed to access the port, so we know that that's switch port security, and it's going to be the maximum, and it's going to be 2. So 2 is the maximum number of addresses. So learned MACs are added to the running configuration, and so that's the sticky MAC. So switch port security, MAC address sticky, and that is going to learn the MAC address, and it's also going to add it to the running config. So if I do a do show run on 06, do we have anything there? So it says MAC address sticky. We don't see anything yet. So let's check. The next one is secure the interface so that a notification is sent when there is a violation, but the port is not disabled. So that is, there's 3 choices here: switch port security, violation mode, and we have 3 choices: protect, restrict, and shut down. So it specifically states not to disable the port, so we know that shutdown is out of the question. So it really comes down to protect and restrict. And if you watch any of my other videos on this, on port security, we know that protect does not generate a log message. So restrict will generate that message, that notification, when a violation has occurred. And so then we'll put the restrict in there. All right. So that's been done, and you'll notice we're at 97 out of 100. And so I think that this is where I know that 2 of those points are going to be tied up in what I found to be an error. But the first thing we want to do is, this is verify that the PCs in the same VLAN can ping each other. Right? So I'm going to pull up PC4 here. Oops, sorry. I'm going to pull PC4 up here, go to the desktop, and the ping command, and we're going to say ping. So PC4 is in VLAN, it's on port 11. Excuse me, so VLAN 10, which is sales, and so I'm going to go ahead and try to ping PC1. So let's ping 172.31.10.21. All right, so we've got success there on VLAN 10. So let's try PC5, and PC5 is in FA018, and we know from our assignment here that's VLAN 20, and its corresponding neighbor on the other side is PC2. And so let's go ahead and ping, whoops, let's ping 172.31.20.22. All right, fantastic. We're not having any issues there. And then finally, PC6 is in FA06, which is VLAN 30, and his counterpart on the other side is PC3, 172.31.30.23. All right, fantastic. So real quickly, and I know that this isn't in here, but if I'm on PC6 and VLAN 30, what happens if I try to ping PC1, 172.31.10.21, right? Nothing, right? I'm unable to ping, okay, because these are not multi-layer switches, or they could be, but IP routing is not configured. So basically, these trunk ports here, the gig 02 ports here, and then the gig 01 ports here, they're simply allowing the VLAN information, right, and these VLANs to traverse the trunks to then make it over here from switch 3 over to switch 2, and then out the proper VLAN. But as you can see, there is no routing setup here because I'm unable to ping across the VLANs. So from VLAN 10 to 20, it won't work. 10 to 30, it's not going to work. So that's a good quick point there. So now we've got 97 out of 100. And so if we check our results here, let me drop that down. If we check our results here, all kinds of stuff going on there. All right, so, and this is what I had seen earlier. For some reason, it's asking for the port status on 14, 24, and 4. It's looking for port security on those ports, right? And so on switch 3, if we go back, so it's 14, 24, and 4. If we come back over here, you'll notice that 14, 24, and 4 are not even on this diagram. And I don't see anywhere where those ports are listed here or that we need to do anything to those ports. So it's always good, you know, if you're short your points and you don't have 100 out of 100, that you go take a look. And so then let's pull those ports up. So if I do int FA0/4, and I'm going to go ahead and add the switch port, port security, switch port, port security, maximum 2, switch port, port security, violation restrict, and then switch port, port security, I think it was MAC address sticky. All right. So we've added all that in there, and you'll notice that it still shows 97 out of 100. So if I do a do show run, and let's take a look. I think we're looking at 4 right now. You can see here on 6, it has learned the address and it's in the running config, right? So that's MAC address sticky. So 4 has been set up here, right? And we've added the port security as it said was lacking. But if I do a show IP interface or show IP interface brief, 4 is down and down because it's an unused port. But watch what happens if I do a no shut, and let's see if our point total reflects that over here in the corner. It still shows 97. So what I did earlier was I did a no shut and then I did a shut. And as soon as I did that, it said that the port, even though it was administratively down, right, or it was down, if I do the same command again, that do show IP interface brief, you can see now it's administratively down. So for some reason, these other ports being just in the down state, nothing plugged into them, that's okay, but it's specifically looking for us to administratively down those other ones. And so if we come back over here to where it said disable unused ports, so if I were to go ahead and do a range of ports that are unused, it would be interface int range FA 0/1 to 5, and then do shut, and then do interface range FA 0/7 to 10 and shut, and then interface range FA 0/12 to 17, and then shut those down. And you can see we're getting the points now, right? So without the port security in there, we're still getting those points. And then finally, it would be interface range FA 0/19 to 24 and shut. And that should give us those last points, and it does. So even though the results were saying it was a port security issue, it really wasn't. It was that they weren't administratively shut down, right? And so now that I've administratively shut those down, I'll do a do write mem to save my config. Okay, we've already tested our connectivity, so we're good to go. And that is PacketTracer 3.4.1.2, the Skills Integration Challenge. Hopefully you found some value in this video, and I always like to hear feedback if you found it helpful or if there was something else you were looking for. So that's it on this one. Okay, best of luck to you in your studies, and remember that the oasis of success lies on the far side of the desert of failure. So keep plugging away and share your knowledge with others. All right, have a great night.